So I'm just gonna, if nobody's got one, I'm gonna work through a couple, and then if you know this one, feel free to ask, okay? I think you would agree that if you know everything on the review sheets, the tests we had so far, I mean, there aren't really that many surprises on the test, so it's really important we know how to do all these problems. So, I want to look at number 6. I'm on the no calculator part, and I'm looking at number 6, and I'm going to describe the end behavior of this curve. Now, end behavior always means this. This is my notation for end behavior. That is the official, legit notation for end behavior. Okay? Now, this is no calculator, so you're not just going to type that in. You're going to have to stop and think about this for a second. What is the degree of the polynomial? 17, which is an odd number. Odd degrees start down here and end up here. Right now, I don't care what's going on in the middle. This is the general shape of an eye. However, this one has a negative in front, so its general shape is going to be like this. So in other words, as we go to the left toward negative infinity, the arrow is shooting up. But as we go to the right, because this is not the one I'm using, as I go to the right, positive infinity, the arrow is shooting down. Got it? That problem should take you 4 seconds to do, right? Don't find zeros, no synthetic division, nothing like that. We want the end behavior. How does it start and end? Okay. Another one I want to do, because for some reason people miss it, is number 2. It's a quadratic function, which means it's x squared. This is number 2. I know the vertex is -2, 1, and I know that f of 3 is -7, which corresponds, by the way, to the point 3, -7, because f of x is 3, y is -7. Okay. Now, quadratic function, that's one of your BFFs, and it looks like this, right? Memorize that. That's your y equals x squared. You have moved the vertex, though. Instead of being at the origin, you have gone 2 left and 1 up with your vertex now, right? So how do you adjust your equation to reflect that you went 2 left and 1 up? All right?
Wouldn't it be in parentheses?
Yes.
Plus 2.
X plus 2, perfect.
And then
How do you get up
minus
1?
1.
Oh, plus 1. Plus 1. Now, something's missing in there, though, that's kind of important. You need the squared. Remember, it is a quadratic, so you got to keep the squared on the x, right? Okay, we're halfway there. That is the kind of the foundation of your equation, because that's where the vertex is. Now, how do you find your leading coefficient that's going to determine how skinny your parabola is and which way it opens? What do we do?
You plug in 3,
You
-7.
take the other point. Always use the vertex to build your equation. Then take that other point and plug it in and do the math. When you do the math, please do it carefully. 3 plus 2 squared is 25n. Plus 1. Don't add 25 and 1. They don't add. Did you get -8/25?
Yeah.
So when you write your answer, keep in mind the question was quadratic function. So I'm going to write my answer. like that. Everybody okay with that? All right, let's flip it over. Let's look at 11B. Sketch it labeling all of the intercepts, asymptotes, and poles. So 11B, again, this is no calculator, so you aren't gonna have a calculator to jumpstart you. You are totally on your own, but you can do this. You can do this. How should we start? What should probably be the first thing we do?
If we can factor.
The first thing we should probably do is factor it, because there's a chance, I don't think it's gonna happen here, but there's a chance that when I factor, I'll be able to cancel, and what I thought was gonna be an asymptote then would become a pole. So before I start graphing anything, I think I'll go ahead and factor. Doesn't do me any good in that regard. It is helpful, we use that, but nothing cancels, which means this particular thing will have no holes. But it will have asymptotes. It will have a vertical asymptote at -10. And it will have, there's no horizontal asymptote, but there is an end behavior asymptote, right? There's always an end behavior asymptote of some kind. Sometimes it's horizontal, not this one because the powers don't match. So I'm gonna have to do the division. So I'm literally gonna do this division problem. So 1, 20 is gonna be divided by x plus 10. Whoa. All right, double check that. Did I do that right? Okay, now the good news is, when I'm doing my end behavior asymptote, that number doesn't count. So my end behavior asymptote is simply going to be y equals x minus 9. Which is a line with a y-intercept at -9 and the slope of 1. Okay, that's supposed to be a straight line. I realize it's not, but it's supposed to be a straight line. Okay? Those are my asymptotes. Now, where are my intercepts? Well, that's what this factoring up here is useful for. Because what happens if you let x be -5 or +4? You get 0. So 1, 2, 3, 4, -5 is a 0, and 1, 2, 3, 4 is a 0. Those are my x-intercepts. My y-intercept, if I let the x's be 0, it looks like my y-intercept is at -2. Would everybody agree with that? Putting in zeros for the x's? Now, based on what I've got so far, that's it as far as requirements. My job was to put in all the asymptotes, I did it. Put in all the intercepts, I did it. Put in all the holes, we didn't have any. So now I have to figure out what it's gonna look like. So in here, I think it's gonna do something like this. Would you agree with that? That's supposed to be kind of like that. Now here's where we get in trouble sometimes, especially when the picture comes out like mine did. That is the right side of the vertical asymptote. Remember, this cuts your picture into two pieces. The right side, which I graphed, but there has to be something on the left side too. Where is that going to be?
Down there.
Clear down here in the corner. This is very bad, but it's clear down there
So,
in the corner. Remember, whatever is happening on the right side, or excuse me, the left side, whatever's happening on the left side, it has to follow the asymptote. So it could have done this, but it really can't because it can't cross the axis. So the only thing it can do is be down there.
Wait, why couldn't it cross the axis?
Because I've already plotted all my intercepts. That's why we do the intercepts first. That's where we cross the x-axis, and that's only where we cross it. Okay? Let's do one from 12. Which one in number 12 shall we do? C? Now, C looks like a disaster, but in terms of actually doing work, C isn't too bad. Because, look at this on my number line. If I let x be 4, then the thing would actually equal 0, right? And I can't equal 0 in my problem, so I'm going to put an open circle at 4. That's what would make it equal 0. Now, will my denominator ever equal 0 in real number land? No. So I don't need to worry about that, but normally I would. Normally I would have to worry about my denominator being 0, but not this time. Now, I want this fraction to be positive. Well, I want you to look at your top and your bottom. Isn't the top always positive? Except when x is 4, which I've already ruled that out. Isn't the bottom always positive in real number land? So isn't that fraction always positive? Except for this one place where it equals 0? So my answer is everything except 4. So that one was easier than it looked, for sure. Finley?
How do you do A? Because I know that square is weird.
Yeah, you would factor it and figure out where it equals 0. So it equals 0 at -4 and 4, right? Well, since it's an or equal to problem, I can actually color those in this time. And then I'll pick a number somewhere, like, I don't know, 0. So if I put 0 into my problem, 0's in here. If I put 0 into my problem, is it true or false? True. That means wherever 0 is gets shaded. And remember our every other rule, you can use it if you want, or not. You can check -5 and +5, but this would be the answer. Because they're not gonna work. They're gonna come out positive.
I can't remember, what was the exception to the every other?
If you've got squares on your factors, or if you've got a funky factor like this.
Okay.
But as long as you just have straight factors, it's always gonna alternate. All right, let's take a gander over here at the word problems. Okay, number 3. I know we've done a million boxes. I know we've done mixture problems. I'm not sure about number 3. Have we done problems on number 3?
No.
Well, then we best do it. It's real easy. You actually have done that. Yeah,
One
you-
over X.
Yes, you've done these last year. So, but they are 1 over alone plus 1 over alone equals 1 over together. So what's happening in this problem is you got Bronson and Ben doing the homework individually and then doing it together. Okay, so this means 1 over Bronson alone, so however long it takes Bronson, it takes him 6 hours, so 1 over 6. Plus 1 over X, because I don't know how long it takes Ben to do the assignment, equals 1 over their time together, which is 4.5. So the setup for these will always be 1 over alone plus 1 over alone equals 1 over together. If there's 3 people, then you got 3 of these adding up to 1 over together. Occasionally, you'll have to have a minus in here. So, for example, if I had a hose running into the pool and a drain running out of the pool, then those wouldn't be added together, they would be subtracted because they're working against each other. But the idea is the same, it's still 1 over equals 1 over together. Okay, so then how do we solve something like this?
Get a common denominator.
I would get a common denominator. Personally, I would multiply everything. But I could simplify that, but since I got a calculator on this, I'm not gonna mess with it. So I'm gonna multiply everything by 4.5, 6, and X. That will wipe out all my denominators. So this one's gonna be 4.5X. This one's gonna be, what's 27? And this one's gonna be 6X. So 1.5X equals 27, so whatever 27 divided by 3 halves is 27 times 2. So you get 18? So it takes Ben 18 hours to do the assignment by himself. All right, let's look at our Beasley Cannery problem. Number 4. All right, so here's the can. The can has to hold 1,500 cubic centimeters of stuff. So the volume has to be 1,500 cubic centimeters. And how do we find the volume of a can? Pi r squared h. So that right there is something. I have to find the radius of the can that will minimize the surface area. The surface area is the amount of aluminum I need to make the can, right? So, how do I find the surface area of a can? 2 pi r squared, that's the top and the bottom, the bases. And then remember, we open up the sides of the can, it makes a rectangle, right? So that's
2 pi r.
2 pi r h. And this is what you want to minimize. So you're going to type this in on your calculator and graph it and find the low point, but there's a problem. What's the problem? You got 2 variables. So we need to go back up here. This is the one I need to get rid of. So isn't h equal to 1,500 over pi r squared? So I can plug that in right here, so I have 2 pi r squared plus 2 pi r times 1500 over pi r squared. Let's simplify that before we go to our calculator. So 2 pi r squared plus, pi's are gonna cancel, one of the r's is gonna cancel. Did you get 3000 over r? That's what you're gonna minimize on your calculator. Tess?
This is like 0.5 liters, is that 500 centimeters?
Yes, because didn't we look it up one day, that, the relationship between, I think a milliliter is a cubic centimeter. So there'd be 1,000
And one.
in one, yeah, so 500 and a half.
Okay.
Oh, I didn't even check that though. Were these units all matched up okay? All right, so here we go. Here's my equation. Ooh, I have a sometimes I have to play around with the window, but this worked out for me in my first guess. My lucky day. I want the minimum now. Make sure you're looking for the right thing. You're looking for a minimum. And anybody got it yet? The minimum point is, did you say 6.21, comma 725.40 basically? Oh, it is 6.20, thank you, I remembered wrong. I really not an age. When you're my age, things don't look right, but yeah, 6.20 and 725.40. So let's answer the question. These are the ones we always have to be careful. Find the radius of the can that will minimize the amount of aluminum. So remember, when I wrote my equation here, I have r's, but when I typed it into my equation, or into my calculator, that became x, right? So isn't the radius just the x coordinate? So that'll be 6.20 centimeters. Okay, let's look at the next one, because we did one of these the other day, but I think there's still some confusion amongst some of you. So we're gonna publish a paper. Here's the paper. The area of the written work, now you all have read things on the page. The written work doesn't go from edge to edge. The written work's here in the middle, and it's 220 square inches. The top and right margins are 1.5, and the left is 1, and the bottom is 0.75. We want to find the dimensions of the paper that will minimize the area. So we're going to do another minimum problem. We're going to minimize the area. So, what is the area of this page? Well, first of all, what are the dimensions of the written work if the area of the writing is 220? I can call this x, and what would this be then? Not x over 220, 220 over x, right? Remember, they have to multiply together to give me 220, right? So 220 over x and x. So what is the width of the entire page? Well, it's this x plus 2.5. That's this across here. It's that x, a 1 on this side, the 1.5 on that side. What's the length of the entire thing? 220 over x plus 2.25.
So why is it 220 over X?
All I know is the area, so length times width has to be 220. If width is X, then length has to be 220 over X, right? Now, since you're going to your calculator, if you want, you can just leave it like that. If you don't want to take the time to multiply it out, your calculator will graph this just fine. Or you can multiply it out, simplify that equation if you'd rather. Make some minor adjustments here. There we go. All right, you guys probably have it by now. I don't. Just give me a minute. Took me a second to get my window figured out.
Can you put this into the charger?
Okay, for my minimum, I got the point 15.63 and 295.98. Anybody else get that? You got that? Good. So now I need to answer the question though. This is the minimum point. So what does this represent right here? 15.63, what's that?
The side of the paper written.
That's the width of the writing, right? So this is the width of the writing. What's the 295.98?
Area.
That's the area of the whole page. So what does the question want? Find the dimensions of the paper. So basically I don't want either one of those numbers, right? I want the dimensions of the paper. So the dimensions of the paper are 15.63 plus 2.5. So 18.13 is one dimension of the paper. Would everybody agree with that? And then the other one is 220 divided by 15.63 plus 2.25. 16.33. I'm going to do a quick check. If I multiply those two numbers together, what should I get? 295.98. I'm really close.
So
Round
could
off
we
there.
just divide the total area by
Yep,
the
absolutely,
calculator?
absolutely. And we might be off a little bit, Leah, because round off, but we should be really close. Okay? All right, let's do that last word problem, and then they can do whatever you discovered.
Area.
Okay, so Mallory serves $180 volleyball practice.
Because they were just asking for this.
And there are 400 minutes of practice. The coach insists that for every loss of 20 minutes of practice, she will need to serve 12 more times. Find the number of minutes of practice that will maximize the number of serves. Okay. So right now, she is serving 180. I don't like the way this problem reads. Every loss of 20 minutes of practice. So let's let X be the number of changes to practice. So the minutes are 400 minus 20x, does that seem right? 400 minutes, losing 20 every time, chunks of 20, increments of 20. And that's that. And then we're doing 180, this is the part that confuses me.
Is it 180 plus 12?
Plus 12.
Well, it would be, I get that, but am I multiplying these together? That's what I would need to be doing in order to get a parabola, but it doesn't really make sense. I tried to get creative and it's not really, but does this setup make sense to you? Okay, so take my word for it, we're gonna multiply them together. Now, multiplying them together is gonna give me what piece of information? This is minutes times volleyballs, but it never really says that that's 180 volleyballs every minute. It's per week and the weeks and minutes don't match. But does that setup make sense to you? That this is starting with 400, losing 20 every time, starting with 180, gaining 12 every time? Okay, so let's go ahead and multiply it all together, because it says something about a maximize. So I need a parabola here. You could graph this on your calculator if you wanted to, but I think sometimes setting the window up takes more time than just doing a parabola by hand. I did some of that without a calculator, so I'm gonna check. So my equation is negative 240x squared plus 1200x plus 72,000. Now, again, you're going to have a calculator. So you could graph this on your calculator and find the maximum, but you can probably more quickly find the maximum doing negative b over 2a. Because it is a parabola. So negative b over 2a, did you get 2.5?
I keep getting a line.
I got 2.5.
So, what does that 2.5 represent? The number of times I make a change? The question says something about serves. So which of these two parts of the problem involve the serves? This one does, right? So if I want the maximum number of serves, I'll do 180 plus 12 times 2.5. So what are the maximum number of serves? 210. What would this part of the problem tell me? How many minutes?
I think that's what they're
Right?
asking.
Isn't it asking to find the number of minutes?
Yeah.
Oh, it does.
Uh-huh.
Maximize the number of serves, but it says find the number of minutes. So let me plug it in here.
Wait. How did you get 12 divided by negative 40?
350, is that what you
Oh,
got for you? 350 minutes?
I don't know.
So you're exactly right. I gotta read the problem. Find the number of minutes that will maximize the number of serves. So the maximum number of serves is 210, And the minutes that will produce that is 3/4. Yes? What? Okay, I said that. I didn't, this problem is not, it's supposed to be one of those problems like income, but I messed it up. The structure is what's important. So you understand where this parentheses came from, and you understand where this one came from. Okay, take my word for it, we're just gonna multiply them, because that's the only way we're gonna get a parabola that we can maximize. The problem itself really doesn't make much sense, because I tried to do something a little different, and I didn't do a very good job of it. But you need to know these parentheses, right? And then we found the maximum. Okay? All right, so have you found anything else? We've got 15 more minutes. I just went through and did random problems. Yeah, what else? Is there anything else that, as you're looking through it, you're not sure what it's talking about or how to do it? All right, let's look at number 9, because it's worded a little bit differently. But I think you know how to do it. It does say do not multiply out, so you are writing a cubic function, and you know that f of 1 is 0, f of 2 is 0, and f of negative 4 is 0. Right? So that means if you were graphing it, wouldn't those be your x-intercepts? Which, they're your zeros. Exactly, they're your zeros. Which means we're going to use those to build your factors. So whatever this equation looks like, we've got x plus 4, x minus 1, x minus 2. Because the zeros, the x-intercepts, give you the factors. Now, we're not going to put any squares or anything on here, because the problem stipulates that it's cubic. Isn't this going to be cubic? So I'm done. I don't have any powers or anything. I do need to figure out what that leading coefficient is. But I was given an additional piece of information, right? That is the random point, -1, 6. So in goes the 6, in goes the -1. I'll do the arithmetic. Keep an eye on that arithmetic. I got 1/3.
That's fine.
That's what you got? So it says write the equation, do not multiply it out. So the equation is just going to look like that. So that's an easy problem, but it was written a little bit differently there. So I want you to keep in mind that when we say f of -4 is 0, that means -4 is a 0. That's an x-intercept, which produces. All right, that one caught my eye. All right, what else? Anything catch your eye?
I've just got a quick question for
Yep.
number 8.
Number 8?
When you're doing the synthetic division for -2, do you put -2 right into it, or do you do 2?
When you're doing the synthetic division, we use -2. The only time we would change the sign is if it says, is x plus 2 a factor, or something like that, then you would put -2 out here in the box. But in this case, the number is already -2, so I'm going to do the synthetic division. What is the tricky part about this is, you got a 0. Hopefully you noticed that. You can't get the right answer of a synthetic division problem if you don't put the zeros. Ooh, I erased something. You don't put in the zeros. Alright, so let's see. Check my arithmetic there. That look okay? So question is it a lower bound? And the answer is
Yes.
Yes, they alternate.
yes. And then does it say why or why not explain? How do we know?
It alternates.
Because it alternates back and forth, right? From positive to negative. That's how you know you got a lower bound. Yeah. 7. Using the function in number 6. Okay, so that's that big thing.
Wait, if it's, I say it's like the same as 4, yeah, just like up or down, but all positive.
Alright, so y equals negative x to the 17 plus 47x cubed minus 10. List the possible rational roots. Factors of 10 plus or minus 10, 5, 2, and 1 over factors of 1, right? Now, since it's a 1, I don't need to worry about it, but I need you all to be clear about this. It says list them, it says find them. I will say, oh no, it says list, it actually says list. So we need a list of numbers. So there isn't one, but let's say there was a 3 out here in front. Okay? Then that would look like this, right? Factors of last over factors of first. That's not a list. The list would be 10, 5, 2, and 1 over 1, and then 10, 5, 2, and 1 over 3. There is the list. Okay, so if you are specifically asked to list, make sure you have a list. Ours, we didn't really need to worry about it because we had nothing in the bottom. So that is it for that. All right, and then it says, how many negative real roots are possible? So usually when we do Descartes, it's rule of signs, we are finding positive reals, negative reals, and imaginary. Well, this particular question was only the negative reals. So we go back to our problem, and we pretend that x is a negative number. If x is a negative number, this guy right here will be positive. This guy will be negative, and that, of course, will be negative. Well, how many times does the sign change?
1.
So there is 1 negative real root. Let's go ahead and do the positives and the imaginaries also. So to do the positives, we just count the changes in the original problem. So we go from negative to positive,
1,
and from positive to negative.
2.
So 2 or 0. How many roots does this equation have altogether? 17 of them. So if 2 are positive and 1 is negative, that would leave 14 to the imaginary. But if there were no positives and 1 negative, that would leave 16. So this thing, if you graphed it, it's either going to cross the x-axis once, or it's going to cross the x-axis 3 times. There's going to be some other wiggling around in other places, but that's it. By the way, see these numbers right here? They have to be even. So if you're doing it and you get a 13 down here, you're wrong. because these gotta come in pairs, so that's gonna be even down there always.
There's two subdivisions.
All right, anything else you see? Or otherwise I'm just gonna pick a problem, get one more done. All right, I'm doing D, 12D. No calculator, 12D. So x cubed minus x squared plus 3x minus 10 less than 0. Since I'm doing this without a calculator, I am not going to do one side and the other side and look where they intersect. I'm doing this without a calculator. So I'm going to get it set equal to 0. So make sure I didn't mess up my sign. Plus 3x minus 10. Is everybody okay with that?
I thought we could have moved X across the,
You can add and subtract it.
We just
You
can't
can't
draw
divide
both
by it, but you can add and subtract it. Adding and subtracting doesn't change anything. Dividing by a negative does. All right, so where do I go from here? No calculator. You're gonna think about your PRRs. Whether you write them down or not, that's up to you. But at least think about them because this does not factor by grouping. So I'm gonna have to guess and divide, right? And that's my list of guesses. So, what do you think? Feel like 5 works? I don't think 5 works. Here's the deal. Here's why I don't think 5 works. Because if I plug 5 in, I need to get 0, right? And that's gonna give me a 125. And I don't think these guys are gonna cancel out a 125. So I like 2, let's try 2. I don't know if it works or not. We're gonna find out. It surely does. Perfect. Perfect. Yeah, it does. So that means that on my number line, a number that gives me 0 is 2. I don't want it to equal 0 though, so I'm gonna mark that with an open dot. If that were or equal to, I would color it in, because that would be a 0. All right, now where do I go from here?
PRRs is 5.
I look at what's left, which is x squared plus x plus 5. Oh, shooty tooty. We don't. I spent yesterday with my mother, and that's my mom. Love you, Mom. She watches my videos sometimes. Okay, so what do I do if it doesn't factor? The quadratic formula. So x equals negative b plus or minus the square root of b squared. Oh, double shooty tooty, because why?
Imaginary.
They're imaginary. Now, kids, what that means is this guy has 2 solutions, but they're both imaginary. Therefore, I'm not going to be putting them on my number line. I want you to think about this guy right here. This is a parabola, right? I want you to think about it for a second. He has a y-intercept at 5, and he doesn't cross the x-axis. I'm just looking at this part of the equation. If his y-intercept is 5, and he doesn't cross the x-axis, then doesn't he have to look something like that? Which means he is always positive. So this part of the problem is always positive.
At the end of the day, and now let us, as is our tradition, pray together. In the name of the Father, and the Son, and the Holy Spirit. Hail Mary, full of grace, the Lord is with you. Blessed art thou among women, blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death.